So this is problem 72. So we're going to start out by doing the drawings. So I'm going to have 3 different drawings altogether. So this is the first one. It's of without the slide. So without the slide, you have this is 1 meter. This is 5 meters. So you have a 1 meter drop and a 5 meters going horizontally. The second drawing is with the slide. So you're gonna have it's gonna look somewhat the same, but let's kind of draw on that slide. So start here, let's draw a slide going up. So you know that this is 45 degrees, and you know that this is 1 meter, and you know that this is 2 meters per second. And then the last thing you need to draw is the right triangle that measures the velocity with the slide. And so you'll know that this is 2 meters per second. And you know that if it's a 45, 45, 90 triangle, then you know that these two must be root 2 because it's a 45, 45, 90 triangle, which means that the sides times root 2 is equal to the hypotenuse. So let's start out by drawing our chart then. So we're going to have 2 different charts. One is for the without the slide. So I'll do that one first. Velocity initial, velocity final, acceleration, distance, and time. And let's do the next one. The next one. X. Y. And initial velocity, final, A, X, and T. So we know our goal unit is the horizontal change in X. So I'll just make a square on that so we know what we're aiming at. So now let's go back and fill in our givens. So we know that VI, so we know that the change in X for Y, the distance, this is 1, or actually negative 1. We know that this is 5. We know that the constant acceleration of X is 0 because it's constant acceleration. It's constant speed, not constant. We know that the acceleration, this is a constant acceleration of 9.8 meters per second squared. And also the other thing we know is the velocity initial of the Y is 0 because it's a horizontal. You're shooting it horizontally with no change in which means that it won't have any velocity going up or down. So let's start out solving the problem because that's what we know. So let's start out. The first thing we're going to solve for is the time it takes for without the slide, the time it takes to fall to the ground. So we're just going to write time, and I labeled it number 1. 1 means without the slide. So the first kinematic we're going to use to solve this is VIT plus 1/2 AT squared. So then we're just going to substitute our numbers. We're going to get negative 1 meter equals 0 meters per second times t plus 1/2 negative 9.8 meters per second squared times t squared. So this is gonna give us. Now we're just gonna add up all of computate the numbers. So negative 1 meter is equal to, these two are gonna cancel. We're gonna get, and then these two. So you're gonna divide that number by 2. So it's gonna be negative 4.9 t squared. You'll divide it by now negative 4.9. So you'll get t squared equals 1 divided by 4.9, and then this is meters, that's per second, squared. And then this should give you t, and you're going to root it, and t is equal to 0.451 seconds. So, if you have t is equal to 0.451 seconds, so let's go fill it in up here, and this is for y actually, so 0.45 seconds, we can round it. And then we know it's the same thing for x because it doesn't change. So, now the next thing we have to solve for is the initial velocity in going in x of without the slide. Let's give ourselves some space. So let's write 1 vi of x. So we're going to start using the same kinematic. So x equals vit plus 1/2 at squared. Plug in our numbers. 5 meters equals vi times 0.451 seconds plus 1/2 times 0, because it's a constant, no acceleration, t squared. We know those are going to go away, so it's going to be 5 meters equals 5 meters is equal to vi times 0.451 seconds. Now we're going to divide it. We'll get vi is equal to 0.451 over 5. So, no. 5 divided by 0.451. Not bad. So, you get vi equals 11.067 meters per second. So let's go plug that in up here. So vi is 11.067 meters per second. So now we have all what we need basically from the first without the slide. So we're going to go on to the with the slide, and the first thing we're going to calculate again for is the time. So we are given, fill in our givens. I forgot to do that. So for our time, we are given that the change in x is -1. The acceleration is negative 9.8 meters per second squared. And and we know that this is going to be √2 meters per second because we calculated that out through the right triangle. So now let's start calculating it. So we're going to use the same kinematic again. -1 meter equals root 2. Actually, yeah, that's negative. My bad. Put it up here. Negative root 2 t plus 1/2 times negative 9.8 times t squared. Now you're going to have to turn it into a quadratic equation. So the easiest way to do this is actually to subtract all the things from the right side and put it on the left, and then I'm just going to use the symmetric property. So 0 is equal to 4.9 t squared plus root 2 t minus 1. And then actually the easiest way to do this, to calculate this one out, is you can either do it by the quadratic formula, which I'm not going to do, but the easiest way to do it is just to plug it in on your graphing calculator